Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to this masterclass. Before we get started, a quick word about CSIA. Probably most of you here today are familiar with the association, but if you are not, all you really need to know is that CSIA's mission is to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. In fact, the BP committee regularly reviews and updates the manual. It's currently on its sixth edition with plans to come to put together the next one. For those companies that want to take these best practices to the next level, CSIA also offers a certification program that includes a third-party audit. Many companies find that this audit is extremely helpful for helping them understand their businesses and scale. With thousands of qualified system integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources from accounting to sales to operations to training 365 days per year. It also means that you and your team can attend the CSIA conference because this annual in-person event is members only. If you plan to attend, a reminder that the hotel cutoff is April 10th and the regular rates end April 15th. In addition to the full conference, there will also be two workshops this year, one on best practices and one for marketing. That means you might want to bring several members of your team if you can. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's just a great way to hear what your peers are up to. A couple of housekeeping notes before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. I also ask that you please turn off any automatic note-taking applications. Those are against CSI's policy at this time, and I appreciate you understanding. That being said, the session is being recorded, and you will get a link to the recording in the next day or so. At this time, I'm turning it over to today's speakers, Nathan and Zach. Take it away.
Good morning, Lisa. Thank you for the introduction. I'm going to kick today's session off with a video and then we'll dive into things.
Music was transformed when software met sound. Creativity unleashed at the speed of code. Phones became smart, then they became essential. Software defines how we connect, live, move, and explore. From music to smart devices to personal vehicles, even space travel is powered by open, software-defined systems. And now, industry is entering its next evolution, from closed and conventional to open and flexible. Transforming industrial operations, breaking silos, unlocking innovation, and making systems open, agile, efficient, and intelligent. And Schneider Electric is at the forefront of this transformation. From the earliest control systems to launching the world's first software-defined automation solution, we are leading the way, supporting industry to become better, bolder, and faster. Step into the future. Experience the limitless potential of open, software-defined automation in industry.
Perfect. Lisa, appreciate the opportunity to be here today. I'm going to migrate over to the PowerPoint presentation that I've got, and let's begin. While I'm doing that, I'll introduce myself. My name is Nathan Henderson. Been working at Schneider for about 3 years now. Part of the EcoStruxure Automation Expert team, part of our software-defined automation offer since the beginning, and really here to help demystify a lot of the message that we've been delivering and really to identify the nuts and bolts of how this is being deployed. My role within Schneider is to support system integrators I'll put my contact information at the end, but please don't hesitate to reach out. My sole role is to empower integrators to have the same content and enablement that we internally have at Schneider to share use cases, value propositions, architectures, to really do a lot of the back-end engineering that is required with a lot of these new offerings. Let me share the screen. It looks like I am. So today we're going to be talking about Automation Expert, and this is fundamentally a software-defined automation conversation. I'm really going to try and highlight what software-defined automation is and parallel that to what Schneider is doing as a next step for open software-defined automation. So to begin, we really have to look at the struggles of the past, what we're coming from and what we're trying to fix. Now, I joined the industrial automation world, again, coming from a industrial automation background. I learned this field from the ground up, and there were a lot of things that are on this list that I just struggled to understand why it was so different and challenging compared to the technology I was used to at the IT world. And this is honestly something that I just keep hearing. This is the way we've been doing things. This is how things are. But reality is, as we evolve, our automation systems are not keeping up with the growth that we've seen in technology fields. You know, we are still very used to and accustomed to vendor lock solutions, the hardware being locked to a specific software, and the challenges of having to modernize that piece of hardware and the corresponding software, and the downtime and engineering associated with that. It's also challenging to get all of the information from the sensors, from the field data up to enterprise systems. There's a host of field bus communications, of protocols, of lack of tools able to push data from the OT systems to the IT systems without third-party software stacks, without tools to help enable that. We're evolving in that respect, but there is still fundamental challenges with this. Scaling up is complex too. Typically, you start with either a PLC level application focusing on a specific skid, and then have many programs managed by a SCADA system, or you make a decision to be a DCS type operation from the beginning. But there's very little opportunity to go back and forth between the two. You're either taking DCS mentalities, or you're going with the classic 61131 controller-based program managed by a SCADA system. And limited interoperability with IT/OT systems. Again, we typically look towards our SCADA tools to enable us. Other than onboard OPC-UA, there's very limited interoperability with some of the enterprise level tools that really are starved for this data, that can do powerful things with this operational data, but the challenge is getting it to them. And then human resources too. We're seeing a decline in talented and very qualified automation engineers. This is something that wasn't taught in universities, that the very few trade schools actually taught. It was typically learned on site through military applications, through on-site engineering, electricians who can growing their skill set. But coming from somebody that graduated recently, it's not something that is discussed. But what is taught to the university students is software tools, is IT-based design environments. And this is something that Automation Expert intuitively falls in line with. This is a tool that embraces values like object-oriented programming, auto cross-communication, auto instantization, that is designed around reducing the engineering complexity, again, for those that are used to dealing with software-based environments. So this is really what Automation Expert is seeking to do. We're looking to break the hardware and software dependence to create a middle abstraction layer. And I'll go over this in a little bit more detail shortly, where the automation code is completely detached from the hardware, where you have this software that can be viewed as an asset and then is applicable to many different pieces of hardware, whether it's what's available today in the market or whether what's available 10 years from now that we can't even predict. The idea is you create your application, it stands alone on itself. It is focused around the physical assets that you program. And then you are freed from being locked to that hardware, from being faced with a modernization challenge 10 years down the line. You have a future-proof code. It's also distributed intelligence. There's a lot of advantage to having a system of one program managed by multiple controllers. Is a lot more challenging to manage multiple programs with manual cross communications being handled by a overarching software that then connects all these programs. There's a lot of manual configuration and work that is needed to do that. DCS, of course, the entry price point is typically quite intimidating. So to take advantage of some of those features and functionalities, you really have to have a continuous process and large scale application to even consider going down that road. This addresses that by giving you the features and functionality of a DCS type system at a price point that is comparable to a SCADA system. It's also application centric. We talked about this. Again, focusing on the physical process. This should come first. Let's build the software around the application that we're developing. And then the hardware is the second thought. Again, the hardware is going to be dynamic. There's going to be new products being rolled out, new features, functionalities, price points. COVID is going to affect supply chains again. War is going to impact the sources in which we procure all kinds of resources. It is good to not be locked to a specific vendor because it presents agility from an operational level to procure many different resources to, again, run this common source code that you've already developed. And then digital continuity. This is really a tool that encompasses a lot of the level 1, 2, and 3 services into one unified pane of glass. What I mean by that is it's not just automation logic. This is automation logic and field device connections. It's built-in HMI. It's built-in historization. It's built-in alarming, built-in visualization. This is a tool that does everything under that level 4 and makes it very easy to push all of this field data to level 4 systems. We can also take data from that level 4 and make actionable real-time business decisions on that processing at the enterprise level. So when I talk about software-defined automation, I can tell you that we are not unique, although I do think that we are the industry leader in embracing software-defined automation. Although I do want to parallel a big difference between software-defined automation as a concept and open software-defined automation as a concept. Schneider has embraced and has always been open software-defined automation. I'll go over that in a bit in a second. But I do want to say that there are others that are doing virtualization of control. I won't name names, but there are virtualized controllers out there that haven't really solved the problem of interoperability. They're still vendor locked. They're virtual controllers for a specific set of hardware, a specific brand. And the vision of the future is really open systems where we, again, abstract the software from the hardware. And then we make it so the end user has the ability to pick the best in class programming development for the software and independently then look at the marketplace and say, this is the best in class hardware for my specific needs. This makes the most sense for me. And of course, there's a broad variety of ways that we deploy things, but really it is the freedom to, again, abstract the hardware from the software. I won't go into too much detail on 614.99 versus 611.31. I will say that software-defined automation is event-driven. It hinges off of the 614.99 standard. The 614.99 standard is really just an elaboration of 611.31. 611.31 is how do you deal with one controller. 614.99 is how do a series of controllers talk. But since this is an IT/OT convergent tool, this is a standard that came out about 8 years after 611.31 as a way to address IT/OT convergence. This is something that is still being realized in the market. But the advantages of 614.99 versus 611.31, event-driven versus cyclical, is a greatly reduced load on the processor itself. This opens up opportunities that a PLC would struggle with because it's usually running at full capacity. But do know that this is event-driven and interoperates seamlessly with IT systems because this is how IT systems operate. Again, the advantages of using an IPC, as I've been down this path, I think the bigger question is, I keep asking, why would you consider software-defined automation, versus a classic PLC system? And the more that I'm in this role, the more I realize that it's not that question. It's why would you consider using a classic PLC when you have revolutionary technology at your fingertips that allows increased cybersecurity, increased computational ability, uh, increased network flexibility? I think the conversation really becomes, why would you consider using PLC based 61131 logic when better and more robust systems exist? Uh, Again, looking at an IPC, the price point ridiculously lower. These IPCs that are on the market now are temperature rated up to a PLC, if not surpassing it. They're fanless, steady state, hardened. You can throw them against the wall like you could with an old Allen Bradley processor, and it will work. That's the value proposition. It has to. But they have so much more power. We're not talking millibytes of memory, megabits of memory. We're talking gigabits. We're talking the ability to containerize a small portion of that IPC for the control, and then open up the rest of that for edge computations, for microservices, for what other needs you may need. With an IPC too, you can also eliminate the need for a cellular gateway or a Wi-Fi gateway in a lot of instances. Again, these machines, depending on how you configure it and what you select, ultimately have onboard communications in most instances. Again, based on your needs, you can configure this. But this is Schneider's IPC. Automation Expert will run on any IPC, any Windows or Linux based device. We have some wonderful offerings, great price points, but ultimately, this is a vendor agnostic and open platform that can run on Raspberry Pis, on lightweight edge devices like this BX1 right here, all the way to full server racks. And I'll show that here in the near future. In cybersecurity, I'm not going to dwell on this much, but it is worth discussing. Cybersecurity with an Automation Expert is built in out of the box. And I think now is absolutely the time to be talking about cybersecurity. It was fortunate, or I guess unfortunate timing, however you want to think about it, that we saw a big cybersecurity risk in our OT networks published yesterday. Again, from the .gov site, this is 6 agencies again recommending that we protect our systems. And really, what it comes down to is the fact that our defense mechanism for cybersecurity is network segmentation, is keeping the OT network as offline as possible, as segmented, as firewalled, as protected as possible. But if somebody were to get into that protected network, there is no encryption, there is no cybersecurity, there is no threat vectors that you can defend against if they're inside of that network. What Automation Expert does is it takes advantage of IT technology, and it utilizes the same encryption technology that we depend upon for our financial transactions, for our government security data. This is the tools that we rely upon, again, to protect our data. So even if you have a bad actor penetrate the system, can do nothing with that data. Nothing can be read, nothing can be written. You need the keys to the programming environment. You can't just tap into the system. And that's the strength of the cybersecurity. It's out of the box ready. There's really no configuration or complex setup needed. It is just by default TLS encrypted, and it's an Ethernet IP communication protocol. So all of these are built in behind the scenes. And because of this, we have achieved 62443.3 certification, again, as a system. But the focus here is that it's out of the box ready to be more robust than the majority of the control systems, or at least field bus communication protocols that are out there, with maybe the exception of OPC-UA. So looking at Automation Expert, I'm going to show this in a couple different ways because it took me a couple different times to really latch on, what it is. We have our traditional architecture on the right. Again, many different tools. We have our field devices connecting to a PLC. PLC is its own program talking to an HMI. Again, if there's multiple programs, these are managed by some Windows-based system. If there's analytics, again, these two are not connected. What we're doing here is we're taking everything level 4 and below, everything that would be going at the field level, and creating a unified pane of glass for that. So field device integration, and more than just field sensors. I'll show this later, but building management systems, cameras, vibration sensors, a whole slew of interconnected devices able to be brought into this one control environment. Now we can do edge analytics and microservices all within one machine. So using Docker technology, again, a small portion of this machine can be allocated towards control, where the majority of this device is, again, for computational ability, data number crunching, data analytics, things that we would typically rely upon level 4 to do for us. Now we can do at the edge, again, in a very low cost and simple way. Again, another way of showing this, again, the classic 61131, we have multiple PLCs with multiple programs, typically managed by a 61131 workstation. This is our SCADA system. It ties all these programs together, but there's manual configuration between the controllers. We have to manually map cross communication. What 61499 promises, what it really entails, is a distributed application. It is one single application mapped across multiple devices. Highly flexible too. You can remap on the fly, and this is a, again, system-wide tool. All the information is shared between devices. Each device has its own programmatic load, but it is one application, and all the information is shared. And this below shows the system abstraction layer. Again, let's make the automation code itself an asset. Let's take the focus away from the hardware and appreciate the investment that we've made in developing this complex industrial application. Let's focus on the motors, the pumps, the valves, our physical process, and not spend so much money investing in a vendor locked piece of software that is going to expire. Let's make that automation code an asset such that as an end user, we can now take our code and be flexible to pick best in class hardware. New product comes out, great. Well, we can jump on that without having to wait 5 years for end of life. But that's really the freedom that this allows. And when writing an application, it's a little counterintuitive to 61131 because it is the reverse of what we're used to as a system integrator. You design using library objects, pre-built validated blocks, or you design your own if you have unique needs. You create your entire application within the build time. And again, I've discussed this. Schneider is leading the market, but with universal automation, I'll talk about this. There is a world where in 5 or 10 years, a end user can choose between their design environment and their hardware choice because the software level is completely abstracted. Now, universal automation org right here, this is the enabler. And I think this is the step that Schneider took that is an industry first, that has never been done in the world before. Universalautomation.org is a third-party nonprofit organization. They manage this common runtime. This is something that has been founded off of a decade of work and collaboration, but to distill it down, Schneider has developed a engineering tool and a runtime environment. In 2001, Schneider gave away the runtime portion to be owned and managed by universalautomation.org. This is now a member-driven developmental path. I can tell you, based on the members that we have in this organization, again, it's started in late 2021, let's just say 2022. The organization has grown by a factor of 10 plus, in the few years that it's been around. And the growth represents what I think the world is crying out for, what end users have been asking for quite some time. Uh-oh. Apologize. I am stuck in a frozen screen. But really, UAO is the one that is driving this common runtime. We are now responding with our engineering tool to what UAO is again member drivenly creating on the runtime environment.
You know what? If anybody wants to copy these slides, they're welcome to reach out to Nathan to get a copy of the slides. Do you want to try to refresh your screen? I don't know what will happen if you do that.
I'm going to pull up the task manager and see if I can identify what's
Okay. Should we pull up
hanging things
Zach
up.
in the meantime? Could we have Zach come up?
We can definitely bounce back and forth. Again, I'm going over high level stuff, but I really wanted to have Zach weigh in on the technical things that you can do with a software defined tool. Zach, I certainly don't mind while I restart things if you want to jump into the demonstration portion, and I can finish it up from there.
Sure, no problem. So let me share my screen. We'll stop yours. Okay, can you see my screen okay?
Yes, sir.
Yep. So, hey everyone, I'm Zach Stewart. I am a systems architect for Schneider Electric. I focus on EAE, which is the EcoStruxure Automation solution that we're talking about today. I've been with Schneider just over a year. I came from a pretty large competitor to Schneider, spent some time in a customer-facing role, and I was also a software developer for a leading control programming software that probably most people in the room are familiar with. I just wanted to introduce you to the build time and kind of give you my perspective of why I left my previous role and came here and what I really like about this software. So as an engineer, I've always wondered why we live in a world where we have 3, 4, 5 different manufacturers. They all make some sort of controller. Those controllers all speak a similar language. But getting them to work together is always a pain, right? And sometimes you need to get drivers in the middle, and everyone's kind of carved out their kingdom. And I always found it strange when I would write code for the platform that I was working on in Visual Studio, and it never asked me, what laptop I was using to write this code, right? So when Schneider reached out to me and showed me the software they had, I was actually really pleasantly surprised to see that there was a solution and that it's already, out in the field and in production and running today and wasn't just a concept. So I'll talk through kind of what's here in the build time and just traditionally what's different from a standard control system. So back in my days as an account manager, I remember visiting customers, and we've probably all seen one where they have a Windows 7 laptop that can't be connected to the internet, that has a specific version of, not to throw anyone under the bus, but like RS Logix 500. And that's for a certain control system that's not connected. And you've got just kind of a mix of all kinds of different controllers in a production environment. They're all very siloed. They're all on different firmwares and different software versions. When we made the jump from relay logic to control logic, that, the controller was a really big deal. And how we stood up projects was really novel for the time. We're kind of at a point now, especially coming out of COVID, where customers have a different set of challenges, and the tools that they're using to try to address those challenges are based off architectures developed in the 90s. So traditionally, when we've built a control system, we've looked at everything from the panel up. So, when a customer decides they want to put in a control system, the first thing they do after they get their IO count is they pick a vendor, right? Once they pick a vendor, they have to pick a hardware platform. Once they pick a hardware platform, they have to pick a software suite. That software suite can change based off the controller family. Almost every vendor has a version of that, right? So it becomes very unmanageable when you're designing large systems to kind of look at everything from a panel perspective. So what you see here is an application that we developed for a customer called Velo in Germany. So they're a valve manufacturer, but they also have a microgrid on site, and they do sort of green energy production, electrolyzing rainfall, and they've got solar capture and everything. So when this application, or any application for that matter, is designed, you're really looking at things from a process and application perspective. So you can see here, we've got a section here for water treatment. We've got a section for electricity production. We've got a section for the microgrid. All of these areas of the plant can be mapped to different controllers, and some of them are, but the management of your application all comes from a single application. So that's already a pretty significant jump from how we do things. I'll show you a couple other applications later, but just wanted to point out, you can build, test, and validate an entire application in this software suite without ever purchasing hardware, and you won't be constrained to a single controller, right? So if I wanted to build an application that was mapped to 5 or 6 different controllers, that would be no problem. And I wouldn't need to purchase those controllers, to validate the application. I can do 90% of it from the comfort of my home office, right? So another thing that's really nice is we have a really extensive set of libraries. So just to give an example of some of them here, these are the ones I have referenced, but we've got quite a bit here that aren't referenced. So when it comes to building an application, 90% of the tools that you need to build the application are already contained in the build time. And we actually do a really good job, in my opinion, of documenting how those things work, right? So I'm going to pull up a web browser that has, this is our general help document, and I'll navigate to some of the library guides. So I'll go here to the application library, and I will go to water, wastewater. You can also do this from the build time. It's just a little faster here. So maybe I go to queue management. Here we go. I can go to equipment. I can go to aeration, and it'll show me these different blocks that we have for aeration in a water wastewater facility. And some of these will also give you an example of what other blocks you need to build the system, how to connect them. And then if you wanted to go even lower, you can get an interface to the block, what OPC UA variables are available, that sort of thing. So if you're kind of just fumbling your way through the application, you're able to get an idea of how the tools you have at your disposal, how they work. If we look over to the Solution Explorer, so I showed how we can include libraries into a project. We have 3 main building blocks here. So we have something called CATs, which are composite automation types. We have something called composite blocks, and we have something called basic blocks. So I'm going to switch applications here. The CAT is essentially a function block that can contain other function blocks nested inside of it, but it also has symbols and faceplates. So what that means is I might have something like a motor VS, which is a variable speed motor. That could be a CAT that would have the control logic contained in it. But when I go to make screens for my HMI, I would also have visual information associated with that CAT. We have a thing called composites, which are essentially just headless CATs. So no symbols, no faceplates, just the control logic. They're blocks that can contain other blocks nested inside of them. Then we have this thing called basic function block. So basic function block is a low-level block. It contains a state diagram and structured text. So let me pull up an example of what that would look like. Here's a really complicated example. This is for a generator management application we wrote for another customer, and you can see this startup sequence is fairly complicated and involved. So there's really simple examples, there's complicated examples. All the code here is in structured text. And we also have a debugger attached with this, right? So if I wanted to validate the functionality of the block, just this singular block, I can run this debugger here. And I could simulate the inputs, send the events, and then just verify that the outputs I'm seeing are what I expect. If I were to go back over here just to show some of the canvases. So for water treatment, for example, I mentioned that, we have these things called CATs. This water treatment here is a CAT. I could keep clicking, and keep seeing like the nested layers that are there. The nice thing about this is that is the control logic. Now, if I switch over to canvases, now I have, an HMI screen that's built off of these symbols that are contained within that cap. So the neat thing is, as an integrator, if you build up your library and you've put in all the work to test and validate your objects, when it comes to scaling up or building different sizes of systems, it becomes pretty easy. So this water treatment facility, I can just drag this over. Now I have 2 water treatment facilities. So I'm going to do a little hand waving on some of the connections here. And then I can point it to a controller that's going to be controlling it, right? So I can say, hey, this is going to go to a 580 controller, a 251. Those are Schneider branded PLCs, but there's nothing stopping me from pointing this to, a server in some IT room that has our virtualized control running on it. The same way that I did that in the control logic would be the same way that I do it in the application logic. So I drag and drop it onto the canvas, I copy it, but also on the HMI screen, I can take this water treatment object and I can drag this to the canvas. So now I have 2 water treatment sections in my plant, and the logic and the screens for both were really just drag and drop. If I start this HMI up, remove this here. I didn't like that I added something while I instantiated it. Okay, so I'll move to a different section. So that's how the HMI screens are developed. Again, we have a built-in HMI. The really thing that's nice about it, we have an OPC UA server that could serve third-party SCADA systems. Because we own Aviva, we have some really nice synergies with system platforms. So in the same way here that I built this local HMI and had those symbols and faceplates ready to go, I would have a similar experience with system platform. When it comes down to hardware, I'm going to switch to another application again. Not only can I take my application logic and templatize it in a function block, but I can also take the interface that I have with external devices, maybe over Modbus or Ethernet IP, and I can also templatize those also. So we have application cats and we have something called a hardware cat. So that's what you'll see here. So here I have 4 generators. Each of these generators has an interface with, different electrical set points of real, reactive, apparent power, scaling factors, all those sorts of things. Those are going to be identical for every generator. So if I wanted to add a 5th generator, I'll click add here. You'll see I have a pop-up window. Can't remember which one it is. I think it's this one. It'll tell me I'll have to redeploy if I'm online, if I make a modification. So now you can see I have another interface here. This would be, Elgin 5. So this would be the 5th generator. So not only can I take the hardware interface and duplicate it, but I can also take what we call our symbolic links. Other people might call them global tags. But how we point data points within the application to the hardware is through symbolic links. So this configuration I can import and export. But I can do the same thing with symbolic links here, right? So you can see I have this export button. Now, if I go to desktop, it'll take a moment here. But you can see now I have all my symbolic links for everything that's mapped to this resource, right? So you can see how I have them for different groupings of generators. Where this becomes really nice is you make these connections once, and then, through Excel or Python scripting, it becomes really easy to change these connections as you scale up. So you're not manually pointing tags to each other. So that's how we connect to external hardware. Another thing that we can do is based off the hardware that we're mapped to, This is now a third application I'm showing you. This is a well site application that we built for another customer. This is actually mapped to what we call an ATV DPAC. So it's a compute module that you can put in Altivar drives. So when this becomes mapped to an ATV DPAC, what I can do is I can make another canvas again. I'll go to embedded IO. And I can take like the embedded IO from the drive that I'm connected to, and I can just drag it out here, right? So I didn't need to use C# and make any of these symbols or anything. This is just all built into the build time application. And this is some of the stuff that you just kind of get for free that you don't have to develop on your own, right? So when I map this to an ATV DPAC, all of these DIs and everything that's connected to it in the hardware configuration, I can get a visual representation of it here on a local HMI or on an HMI that we deploy in the field. And you're also able to see those values and force and test. See a couple other things. So we have data types, we have functions. So for the more like programmer savvy types, we can make things really interesting. We also have a thing called adapters. So what that means is we can take multiple data points and we can contain them in one adapter, right? So this could be 20, 30 different variables. Maybe you don't need to spend the time connecting 20, 30 variables externally. You could just put them in an adapter type. And this is what we call single line engineering. And that's where that comes from, right? So it really cleans things up as you're building applications and makes them a lot more maintainable. Earlier, I mentioned a virtual controller. So the way that we deploy to hardware is we either have UAO compliant hardware that would be your traditional PLC form factor. Those are, firmware driven devices and you just deploy to those devices. We also have industrial PCs, right? So I could take this application, I could deploy it to any vendor's industrial PC as long as it's a Debian based operating system, Ubuntu or Windows, and I'm not going to check who the vendor is, right? And the application isn't going to check either. If the runtime's present there, that's all that really matters. So let me close some of these out. And I'll walk through how you deploy an application to the virtual controller that's built in to the build time device, and then I'll walk through how to do it with physical hardware. So here we have a well site. It's pointed to this ATV DPAC. I can verify that here. Let's say that I've designed this, right, and I've built everything up. This is what it looks like under the hood. Got PID control, inputs, totalizers, start, stop. Now I want to validate the logic. So I come over to this deploy window, and up here we have this active network profile. So local test means use the virtual controller that's contained on this computer. Default means use real hardware. So I'm going to use local test. I'm going to press this green button. When I press this button, there's going to be a bunch of steps that are contained. Here's what's happening on the other window. This is our virtualized runtime. I'm going to log into this device. We don't need to check any of these boxes because we're not on real hardware. So now I'm going to deploy. It'll take a couple seconds. This program is relatively small, so it shouldn't take too long. For the non-colorblind people in the room, there's some nice red-green status indicators here that'll become helpful as you deploy to more devices down the road. But unfortunately for me, I struggle to see them. So, okay, you can see here we're on step 3 out of 4. We're almost done running, and then I'll show you how you can kind of watch values in the system. All right, in a second now. Okay, there we go. So we've now deployed to this virtual controller. This is what it looks like under the hood. Now what I can do is I can come over to this application, can come over to my pump stations, and now you can see I can add watches to blocks. So this will be a silly example, but I've got this variable speed motor here. It's not running. Maybe I expect it to be running, but it's not. You can see that the stopped here says true. So I can trace the signal back. I can look at what the set point is. The set point's 80, so it's got something there, but it's still not running. There's no alarm, so I know it hasn't faulted. I can come over here to the start stop logic. Oops. And then you can see I've got this HOA switch that's just in the off position, so that the start signal is false. So kind of a silly example, but just wanted to paint the picture of how I can build an application and test it without ever needing to purchase physical hardware to do so, right? I can do it just from my laptop. I'll also say that what's nice about this, if we go back to COVID times, I remember there were lead times every year or two for certain pieces of hardware, right? With this software, you would technically be able to plug a laptop computer that you got from Best Buy into a switch and be up and running, right? It's not advisable. It's not a long-term solution, but it's just kind of details the flexibility that we have here. And then the very last thing we'll mention, I know we're probably getting close on time, is what it looks like deploying to physical hardware. So earlier, Nathan had said something about cybersecurity. So I have these things called logical devices, which that's when I was mapping function blocks to certain control devices. That's what it was using. I have these things called physical devices. Logical devices are the glue between the physical device and the control application. So if I were to start monitoring, so there's no actual controllers on my home network, maybe a printer. But if I wanted to get to the point where I'm ready to deploy to devices, we're not going to let you do it without doing what we call configure security. So what that means is we're going to scan our local network. We're going to look for control devices. And then we're going to put the IP address in. We're going to click configure security. It's going to ask you, is this device who you think it is and do you trust it? You're going to say yes. And once you do that, we now have a tightly coupled relationship with the application and the control device that it's associated to. So I won't be able to take a thumb drive and upload or download a program file. I won't be able to plug in another laptop and deploy to that control device without having the credentials that are tied to the project. So that's the foundation for the cybersecurity. And then from there, that's where we can start bringing in encrypted communication and things of that nature. So I think I will pause there and I'll see if we have any questions.
Zach, I'm ready to pick back up and power through a couple use cases if you want before we jump into the questions. I know I didn't get nearly as far as I would have liked to have.
Okay, yeah, no problem.
I'm going to be quick, but I promise I'll leave time at the end for questions. I am going to go quickly, though, if that's all right with all on the call. We left off at UAO. I'm just going to power through this. Again, this is not a small organization. This represents really a huge international organization of universities, of vendors, of industry leaders across every vertical. This is, go ahead, Lisa, please.
Would you like to be sharing your screen?
I thought I had. I guess I will.
I don't see it. Maybe others do.
Is this better now?
Yes, there you go. Thank you.
Perfect. So current UAO members, again, this is not a small list. Really, every major vertical is represented. Where we're seeing the most growth is end users, food and beverage with Nestle, Hyundai for automotive, BASF for chemicals. I could go on, but this is a pretty long list. And again, it's grown tenfold within the past 4 years, which is the kind of growth that I would expect out of something that is disruptive as what we're discussing. It is truly an open architecture. So when I say this, Automation Expert is NAMR 4.0 or NOA, NAMR Open Architecture Compliant. This is a technology that is based off of OPAF and OPAS standards, driven from, again, a truly open and interoperable system. And universal automation is the tool that allows us to do that. The third-party organization, because we no longer own the source code, that allows us to accomplish that, as well as any other manufacturing vendor. This really is saying this is what end users would require, and we're willing to present this solution to them because this is really what is in their best interests. The software can run on a broad portfolio of hardware. Within Schneider, we solve our own interdependencies upon hardware. Classically, with 61131, there would be a different software suite for your drives, for your machine PLCs, for your flagship PLCs. What Automation Expert does, it is one runtime that runs across all of these devices. And if you want to change from machine PLC to a more involved, again, high availability or flagship PLC, then it's no reconfiguration needed. It's one tool that works with all of this hardware, as well as any universalautomation.org hardware or any Windows or Linux-based device. But running on the drives, that's a really powerful use case and one that I really hope to dive into. Again, I'm rushing through things now, so bear with me. But you can turn our VFDs into an effective PLC and HMI, and that is something I have been looking for and can't find anywhere else in the market. You can take our VFDs and turn them into a PLC and HMI. I'm going to repeat that again. We've been doing this. It's a very strong use case. There are a couple different ways that we can do this. Again, we can take a single bank of drives and plug in this Altivar DPAC unit. I'll tell you, this guy is about $250. This slide is outdated, but this little plug-in $250 controller will take this VFD and allow it to effectively act as a PLC. It can execute control logic. It can expose process variables, alarms, interlocks, all of this. It can expose to this local Altivar D-pad. If you wanted, of course, you could connect an external HMI, but that's really up to you. I mean, this is what I see as remote monitoring, very distant, not very often serviced. You can go the classic approach where we're going through a controller and, again, VFDs as a connected product, or again, future-proof, where we're doing industrial PC managing VFDs. This is where I would imagine predictive maintenance as an edge application would be applied. Again, really working as a connected product with those VFDs. But we've seen a lot of OEMs, again, eliminate, because they put out so many units per year, the need for a PLC and HMI. And this is a tremendous cost savings advantage. The Altivar drives on board have a good amount of onboard I/O. You can extend that with another plug-in unit, or you can use a TM3 I/O drop or X80 I/O or Edge I/O drop to be managed by this drive. Again, this can handle up to 8 Modbus devices, so it can handle downstream drives, it can handle I/O drops, it can handle any other Modbus device, again, acting as a controller. Another process OEM machine. Again, here we're doing a lot of power monitoring. Again, a simple application revolves around one single pump with a lot of onboard analytics, but all of this containerized and executable through a VFD and a VFD alone. This is another customer, a copper mine customer down in South America. They have a series of 80 tailing dams. Again, you don't normally go out there as a maintenance personnel unless something is broken. They were at the point where they needed to modernize their old drives. We came in, we told them what we were doing, and what they were able to do is to install Automation Expert within the drives itself. Again, this is not a location that is typically serviced. And because of that, we didn't need a need for a PLC or a full-scale HMI with graphics. We just wanted contextualized information. So what they did is they linked all of their sites, again, using Automation Expert, but they used the drive, took the onboard analog IOs, and added temperature sensors and vibration sensors to the motor to give them asset monitoring. Again, not predictive maintenance, no advanced calculations, but this is asset monitoring on the resources to give them more information on some of these remote resources to determine, well, this is falling out of spec. This also allows you to create interlocks, again, based on device condition. We're looking at vibration and temperature here, some of these built in, some of them you want to add external sensors to, but this allows you to, again, at the device level, at the drive level, add some of this complex logic without the need for a PLC or an IPC. Huge cost savings. Another example, this is a glass factory. This has to run continuously for 10 plus years. This is one of the most critical high availability instances that I can think of, but they're running entirely off of VFDs. Now, this does go to a DCS and they have redundant control, but they're using, again, duplicated systems. Of course, controlling a primary and a secondary motor. You cannot stop, or the whole plant will seize up and they'll have to rebuild everything. But the drives are bulletproof enough and dependable enough that they act as the PLC and HMI. Again, with the ability to fail over to a secondary drive if there's a failure determined here or at a connected device. All of this programmable to the VFD itself. I'm going to skip over this one, although it's very interesting. Please don't hesitate to reach out if you'd like to hear more about this. It's also a wonderful tool for edge applications. You can deploy across, as an OEM, multiple instances, online updates, programmatic changes, cybersecurity pushes without affecting performance, without having to send an operator out to manually plug in a USB and to connect to each individual PLC. There are many different ways we can do this. We have some partners that provide services like this. Again, this is a software stack, a microservice type of solution. Barbara accomplishes this out of the box, as well as some open source tool like Kubernetes. Very technically difficult to set up. Typically, the software stack to implement this, but it's possible. It's possible within this platform, and end users are doing this to, again, push updates to their many remote sites, or as an OEM to push updates to your many different skids that are deployed, again, without having to physically fly out there or having to shut down production. Machine vision. And again, I say machine vision, but I really want to generalize that to all kinds of additional sensors, whether it's vibration sensors, noise sensors, thermal sensors, infrared sensors. All of these are very easily interoperable with Automation Expert. A couple different paths. Of course, the classic path would be your PLC with an HMI. You're getting enterprise data from your machine AI system, and it's sending start-stop commands to your PLC. But we can take things a step further. And this is, I think, the most simplified and really demonstrated value of EAE is we can integrate with the Cognex camera, again, with its own embedded AI that can then send commands to the PLC as far as contextualized data. All of this done, again, at the level 2, level 3 layer, none of this enterprise, but since this is a containerized AI, it interacts with the IPC and can make real-time decisions. If there's a quality control system where a defect is realized, no longer do you need manual operator interference. Now we can have contingency plans in place. If production falls out of quality, do we shut down production? Do we look at certain assets? This allows us to really automate all of those workloads. So again, a couple different applications, machine vision, looking at the quality control. Here we took existing quality control and we accentuated that. We added a cobot to introduce a sorting line where bad quality items were in real time sorted out from good quality items, as opposed to taking that QC data and then reacting to batches after the fact. Saved a ton of money there. Again, another major automotive, they're using accelerometers on their welding machines to again track the location of the welder. They're looking at auditory sensors to pick up the noise of the welding and guarantee that it falls in line with the machine learning models they put into place, as well as machine vision. All of this, again, integrates into the control system. If there's defects, then it's not quality control going to the operator and saying, hey, this batch needs to be thrown out. It is a real-time reaction to a defect anomaly detection. And this is all possible because these devices tie into the control system. You can set up interlocks, alarms, permissives, contingency plans. I'm looking at the time and I'm going to have to cut this short. I apologize. I have more that I wanted to cover, but again, this was meant to just get the juices flowing and to really kind of highlight the interesting ways in which we're seeing this used. I didn't touch on any of the classic replacements, and there's no need to because this is just a different way of doing things. But these are the things that the traditional systems that we're used to dealing with would struggle to do as a turnkey single platform. So I'm going to skip to the last slide. I just want this to be up on the presentation. Uh, my role here in Schneider is to support system integrators. Again, don't hesitate to call me. My contact information is here. I will provide training. I will evaluate bill of materials. I will connect technical resources. I am a resource to, again, enable system integrators to, again, understand this platform and use it more. This is my sole role and responsibility. So please, again, don't hesitate to contact me directly. Uh, I know that we're at the hour, so I apologize for not leaving time for questions.
I have a
But
question. I have a
yes, please.
question. Will you be attending the CSIA conference, and can people connect with you there?
Yes, absolutely. Schneider and myself specifically will be at the CSIA conference. We will have a pretty wonderful booth right at the entrance. Again, I'll be there to answer questions, to talk about use cases, to go over the things I couldn't cover, but we will be there. And again, I want to put myself out there as a resource. Don't hesitate to follow up with me, connect with me, ask questions with me. This is my core directive.
Awesome. All right. Well, I have a couple slides just to finish this thing up. I want to thank everybody for attending today. Thanks to Zach and to Nathan for this discussion. And of course, thank you for attending. And I also have another ask. Please bookmark the CSIA events calendar so you don't miss any upcoming events. I mentioned the conference. As a reminder, the hotel cutoff is April 10th. Regular rates expire on the 15th of April. And the Whova app, where you can connect with other attendees, will be available around April 13th. All right, that's a wrap. Once again, thank you for joining us and have a great day.
Thank you, Lisa.